I'm David Watkins, and for my project I chose to analyze the jumping of a billiards ball. The first thing to analyze is the initial strike between the cue and ball. For this I chose a rotated coordinate system, so all of the motion is happening in the x direction. I used a momentum balance equation combined with a coefficient of restitution equation to come up with the velocities. The sum of forces dt could be neglected because only the cue and the ball are involved in this. There are no external forces. Using these equations, I was able to find the velocity of the ball after the impact to be 13.91 feet per second and the velocity of the cue after impact to be 4.42 feet per second. To make sure that that made sense, I analyzed the energy lost during the impact. To do that, I took the energy before the impact, subtracted off the sum of the energies after the impact, and what was left was what was lost during the impact, 0.284 pounds force times feet. The next part to analyze was the impact between the ball and the table. I rotated my coordinate system back into a standard XY coordinate system and had to evaluate it in both the X and Y direction. For the X direction, I used the momentum balance again, and in the X direction, the sum of the forces external to the system was 0. This is logical because you don't see burn marks on the pool felt every time you jump a ball. Using that, I was able to find the velocity of the ball in the X direction after impact to be 8.94 feet per second. For the Y direction, I couldn't use the same momentum balance because there were external forces. There is normal force acting on the table supporting it from the ground. So I used the coefficient of restitution equation to relate the velocity of the ball in the Y direction after impact to the velocity of the ball in the Y direction before impact, and I was able to find that the velocity of the ball in the Y direction after impact was 5.33 feet per second. Here you can see that the ball leaves the table almost instantaneously after it's hit with the pool stick, and also that the pool stick continues to travel down towards the table after the strike. The next part I analyzed was the cue jumping over the ball. To see if the numbers made sense, I was checking how high the ball should have been calculated to jump. Using a kinematics equation, I was able to find that the ball should have jumped 5.29 inches, and you can see from the picture it's pretty accurate given that the diameter of a ball is 2¼ inches. I also wanted to find out how long the ball was in the air using another kinematics equation, and I found that the time it should be in the air was 0.331 seconds. Using that, I was able to find the distance the ball should have traveled, again with a kinematics equation, and that distance came out to be 2.96 feet, which is fairly accurate to what is shown in the video. And here are my resources. I used 2 YouTube videos and some billiards information from Colorado State University, as well as the weight of a jump cue. Thank you.